Euclid's division algorithm concept. In this video, I'm going to explain to you about the concept of Euclid's division algorithm. It is a technique, okay, or you can also call it as a method to compute or calculate the highest common factor of two given positive integers. Okay, so what does this mean? This basically means you can calculate the highest common factor of two positive integers by using this particular algorithm. And it's particularly helpful where the numbers are large. So let's say, for example, I tell you to calculate the highest common factor of 1365 and 126. One method could be you do the factorization and you find out the answers. But by applying this division algorithm, our work gets reduced substantially. And how does that happen? Let's see. So under this method, what I do is first I divide the larger positive integer by the smaller one. So let's say I divide 1365 by 126. Now, if I multiply this by 10, I get 1260. Okay, I subtract this number 501. In the Euclid's division algorithm, the method which is to be applied comes at point 2. Once you've done this subtraction, okay, you basically then whatever is the divisor, okay, which was there in the previous step is now to be divided, okay, 126. So now I am going to divide this by the remainder, right? So I divide 126 by 105. This goes one time. I write this as 105 and I subtract 105 from 126 and I get 21. The next step is, as long as the remainder is coming, I just now divide 105 by 21. 21 times 5 gives me 105. Okay, and I get a remainder of 0. And that's where the matter ends. And the last of the divisors, which is 24 in my case, is actually the highest common factor of these two numbers. Now, if I just try to put in the Euclid's division lemma, I'm talking about lemma, not the algorithm, which we learned in the previous video, I can just resolve this as well. So, in a Euclid's division lemma, we saw that A is equal to BQ plus R, right? In other words, A and B were the positive integers, right? So effectively what I can say is 1365 is equal to 126, this number, times 10 plus the remainder. Remainder was what? 105. The next time, whatever was the remainder actually becomes one of my values. So I will say that the divisor, which is 126, is equal to 105, which is the remainder, times 1 plus 21. And then 105 is equal to 21 times 5 plus 0. So effectively, if you see whatever I did, I can also express that in the form of Euclid's division lemma, right? But the way the algorithm works is you divide the larger number, larger positive integer from the smaller one. Whatever is the remainder, next time the original remainder will actually be divided by the remainder. And whatever comes the remainder again, it actually becomes the divider of this particular number. And that's the way whatever is the last number that you get actually is the highest common factor.